we were to think about the biggest problems affecting our world, any socially conscious person would have to include poverty, disease, and climate change. And yet there is one thing that causes all three of these simultaneously that we pay almost no attention to, even though a very good solution exists. It's one of the most unreported stories about life in the developing world, and I'm here to tell you about it. In 2005, I was working with a rural community development NGO in Osmanabad, India. As part of my work, I conducted in-depth interviews with women in their villages. I interviewed Meena in a village called Bamaniwadi. At the time, she was cooking lunch for her husband and her 2-year-old daughter, who was crawling next to her as she cooked. Like most women in the village, Meena was cooking on an indoor open fire. Her one-room hut was thick with smoke. By 30 minutes into the 2-hour interview, everyone's eyes were watering, we were coughing, and I could barely breathe. I was horrified when I realized that Meena and her family have to deal with this on a daily basis. Yet this is how nearly half the world lives. 3 billion people cook their meals on indoor open fires. When we think about the biggest killers of people living in poverty in the developing world, we think about AIDS, tuberculosis, malaria. We don't think about the kitchen. Yet every year, over 4 million people die from household air pollution from cooking on a smoky open fire. It's like wiping out half the population of New York City every year. Household air pollution kills more people than AIDS, tuberculosis, and malaria combined. How does this happen? Day after day, for up to 6 hours a day, women like Meena cook their meals on an indoor open fire. And when they do, they breathe in the toxic smoke from the flames, which leads to fatal respiratory diseases. 500,000 of these 4 million deaths are children under the age of 5. The biggest killer of young children globally is smoke from the open fire. So there's this serious problem, and yet we're completely ignoring it. In addition, these open fires have an enormous impact on our environment. The smoke from these fires contains something called black carbon, which is the second biggest contributor to climate change. According to the latest statistics on black carbon, cooking on a smoky open fire creates more black carbon than all of the world's cars and trucks combined. So here's the situation. We have 3 billion people cooking on smoky open fires with devastating health and climate consequences. Solving this problem would have an enormous impact on global health and climate change. And there is a solution: the production and distribution of ultra-clean cookstoves. These cookstoves dramatically reduce smoke emissions and cut fuel consumption. And I'm going to turn it over to my colleague Ryan to tell you more about how this cookstove works.
Thank you, Ethan. And thanks, Google, for hosting us today. So how does this product work? We've got one here. And the process starts with the user feeding fuel into the side of the stove and lighting it just the same way they would their traditional open fire. They use the same fuels, whether it be wood or crop residue or even animal dung. But the difference compared to the open fire is that when they light the fire and heat is released, a small portion of that heat energy is converted into electrical energy. And that electricity is used to turn a small fan, force-feeding air into the fire, bringing oxygen, and making for very efficient, clean combustion. The smoke is almost eliminated, over 90% reduced, and the fire burns much more efficiently, twice as efficiently, so that for any one given cooking task, the user only needs to feed half as much fuel. But it gets even better than that, because as the fire builds and more heat energy is released, more electricity is generated, to the point where it's more electricity than is required for the fan. And that surplus electricity can be passed to a USB port on the side of the stove. You can see in this instance, we're using a small LED light, which can be used to light the cooking area or the home for the evening. But even more importantly, in areas of Sub-Saharan Africa and India, where mobile phone adoption has outpaced the electricity grid, the stove generates enough electricity to be able to charge a cell phone. So it's a really dramatic change from other ways of solving this clean cooking issue, and it provides Ethan and his team a totally different value proposition. This technology is enabled by an electronic device called a thermoelectric generator. And there's a lot of ways to think about a thermoelectric generator, but today let's consider it like a solar panel for heat. So rather than converting light into electricity, we're converting heat into electricity. And this occurs due to a pair of metals inside the device that have a very unique property. When one of them is hot and the other is cold, they pass electrons to one another. So the fire provides a very convenient source of heat, and the cooler ambient air can be used to cool the cold side. And that's the real elegance in this design. It's the dual use of this fan flow. That same air that we talked about bringing oxygen to the fire to make it burn cleanly and efficiently is the air that's used to cool the cold side. And it gets preheated in this process. So the fire gets what it needs, and the user is provided with on-demand electricity. So again, this just radically changes the value proposition that Ethan can offer to our customers.
At a retail price of $50, the stove pays for itself in 7 months based on fuel and electricity savings. And it gets even better. Since the stove reduces carbon emissions, we can take advantage of existing carbon credit offset programs to make the stove affordable to the poorest of the poor. You may wonder why I'm telling you all this. I'm not an engineer. I didn't design this stove. I'm just a guy from Cleveland, Ohio, who has trouble making a grilled cheese sandwich. But after my experience in hundreds of smoky homes across rural India, I set myself the goal of trying to solve this problem. So I tried to help the NGO that I was working with to distribute cookstoves to Meena and her neighbors. We marketed a stove by a large British oil company, but it had some problems. It required expensive fuel pellets, which people didn't want to pay for. And it needed electricity, which many villages didn't have. So it sucked. And understanding why it sucked was my PhD thesis in management studies from Oxford. What this large British oil company didn't understand was how people in rural India interact with their cooking environment. They didn't think about the significance of the cookstove on daily life. What I saw in the months and months that I spent in rural India was that for technology to work, it has to be culturally appropriate. And it's not just this big oil company that got it wrong. So many previous attempts at improving the lives of people living in poverty have failed. And I came to realize that many of those failures did not employ a user-centered approach. They failed to take into account how real people live, their real behaviors and cultural practices. So how to crack the problem of cookstoves? When I really thought about the people that I spend time with in rural India, I realized that the stove was not just an appliance, but the spiritual center of their home. They saw this fire in their kitchen as a domestic god, a deity, and the flame as a spiritual messenger between them and heaven. They prayed before the stove daily and created rangoli, artwork they drew around the stove with colorful chalk to consecrate it, to make it a sacred object. In much of the developing world, the wife is responsible for the cooking, and she and the children disproportionately suffer the health effects. But the husband controls the money. So how could we get both the wife and the husband to want to purchase a clean cookstove? Most men in rural India have a mobile phone, which they hope will help them improve their livelihood. But many of them can't charge the phone at home because they don't have electricity. Usually there's a commercial kiosk a few miles away where people have to pay to charge their phone. In Kenya, people pay $3 to $4 a month to charge their phone. That's 2 days' salary. That's 7% of their income just to charge their phone. But since our stove generates more than enough electricity to charge their phone, men really like this stove. There are also some design considerations. People in different regions cook different dishes. In Guatemala, they make tortillas, and so they need a really big cooking surface. In Ghana, they stir large pots of stew, and so they need a sturdy stove that won't topple. In North India, they make roti, and so they need a really hot flame. So our stove needs to be customized to serve different cultures. So how do we get these stoves to people? why don't we just get $1 billion from Warren Buffett or Google and throw millions of stoves at rural India? It's not a good idea. People don't want charity. The people in rural India, just like you and me, want their cherished objects to be the result of their effort and their economic achievement. Also, if they got the stoves for free and they broke down and they couldn't fix them, they'd go right back to cooking on their open fire. We started designing our business in 2010 and thought that surely by now we'd have a scaled up business. But we didn't anticipate all of the hurdles that come with operating in rural India and Sub-Saharan Africa. For instance, in Uganda, the tax rate on imported cookstoves is 60%. That means a $30 cookstove costs the end customer $48. So we've had to get creative and scrappy and lucky. Last January, the vice president of Uganda unexpectedly visited one of our stove demonstrations in Kampala. He wanted to buy a stove, but wanted to bargain down the retail price. We bargained back. We told him if his government reduces taxes on this life-enhancing product, we can reduce the cost of the stove for him as well as the rest of the country. After a year of negotiations, we've managed to cut our tax rate in Uganda by nearly half. We've also had some unexpected setbacks. Our Ghana manager tried to be culturally appropriate and ate a bush cat grilled in his honor on the stove. Jan spent the next month in the hospital. We've also had some unexpected surprises. Our most successful sales agent in India is also a magician. When demonstrating the stove, Himanshu flicks a lit match from 5 feet away into the mouth of the stove, and it immediately lights the flame. Ryan and his engineering team have also had to get creative and scrappy.
Yeah, we have. And creative design is one thing, but we've had to get creative with the whole supply chain as well. When your customers are very low income and tightly constrained by their purchasing power, pricing is critical. And as Ethan described, with some of the taxes and tariffs that are imposed on us in the markets we operate, there's a really powerful compounding effect on the initial cost of goods. When we first got started in all this, we took a very standard approach to component sourcing for the stove. We understood our system, we knew what each piece needed to do, and we worked with vendors to find catalog parts that could get each one of those individual jobs done. We weren't experts in thermoelectric generators, we weren't fan designers, or experts in power electronics or metallurgists. We took their word for it, really. But over the course of the project and learning more about the task at hand, we realized to really delight our customer and to provide the product at a price that they can afford, we had to do all those things. And so we've asked all the members of the engineering team and the development team to build expertise in totally new areas for them. I can walk you through one example. At the core of the system is the fan. And in the first generation of the stove, we talked to every fan manufacturer we could. And we identified a fan that was a computer cooling fan that was about right for our application. These fans are mass produced with all the benefits of economy of scale baked in. They appear in computers by the millions the world over. So at about $3 a pop, we thought we were getting a pretty good deal. The problem is that even $3 is a really significant chunk of our overall cost of production for this affordable stove. And on top of that, the fan was never designed for our application. So we had to actually purchase a slightly larger version, knowing that it would run not at peak efficiency. That simply wasn't going to work. So we dug in and, like I said, became experts. We studied compact fan design. We brought in tools to do aerodynamic analysis on the ductwork inside of our product. We learned how to control the fans. We even learned how to design the electric motors that power these fans. And the end result was that we were able to shortcut the fan manufacturer entirely, source a motor that could do the job for about 50 cents, custom design our own fan blades that could be injection molded for about 10 cents, run the fan from our own power electronics, and incorporate the rest of the housing into the plastic enclosure already part of the product. And so in the end, a component that costs $3, we now can make for under $1, saving over 70% on that component alone. And we fought similar sourcing battles across the product all over in the metals in the stove, the electronics, the thermoelectric. But the point is that we really had to dive in and become experts. And pricing is one half, but we also need to understand the customer. We push really hard to have every engineer on the development team pay equal attention to our users and the user needs. We spend weeks and months in the field with Ethan's teams, observing cooking, watching household energy management, and sitting down with the cooks to really learn how they interact with the stove, what the potential pitfalls and pain points might be. We learn a lot in this process. I always say a week in the field can be more informative than a month in the lab. And even as recently as late last year, we've made some pretty key understandings during this process. One specific incident late last year, we were watching people cook, and in some regions, for certain dishes, rather than just an hour or 2 hours worth of cooking, they cook nearly all day for 3, 4, 5 hours at a time. And during these really long duration burns, some of the fuel doesn't quite fully combust, and you build charcoal in the stove. This charcoal builds up, and eventually, over the course of 4 hours or so, can fill up the whole chamber. And so you need to remove that charcoal in order to keep cooking, to feed fresh fuel. Well, the problem is we've now got a cook who's pulling out a large burning stick and essentially holding an open fire now in their hand, emitting all the smoke that an open fire does. And what we saw was that during this process of pulling out the burning fuel, clearing the charcoal, and putting it back in, all that smoke we had just saved over the last 3 hours was now emitted into the home. So we knew it was an issue that had to be solved. We came back into the lab. We built out capability to do long duration burns here in our labs for hours on end. We sourced the appropriate fuel to be able to simulate conditions. And we retuned the entire injection scheme to make sure not only the flame was burning clean and efficiently, but this charcoal was fully combusted and used. We eliminated the need for this charcoal clearing exercise. And so I think we're close. We've got the right product. We're zeroing in on the cost target. And it's really up to Ethan and his team to go get these stoves into all the households that need them.
Our business is on track to be self-sustaining and profitable, but it's going to take a lot of patience and capital to get there. Fortunately, we've built this patience into our business model. In addition to selling cook stoves in the developing world, we also commercialize a line of camping products, which we sell to outdoor recreation customers in the US and over 70 other countries. We call this business model parallel innovation. This is not a Tom Shoes one-for-one handout model. This is about reinvesting near-term revenue from the sale of our camping products to incubate the emerging markets business until it's commercially self-sufficient. I'd love to talk to any of you afterward about how we can make this business model even more sustainable. Around 1440, Johannes Gutenberg, an entrepreneur with a great beard, set out to develop the printing press. At the time, scribes wrote books by hand. Yet the challenge of inventing a printing press were daunting. Civilizations had been trying for thousands of years to mechanically reproduce texts. The Minoans, the Greeks, the Chinese. Yet it never took off. In each case, there was something missing that was crucial to mass uptake. Whether it was the invention of paper, or the alphabet, or expanded literacy, or buy-in from religious elites. It wasn't just a technology problem. For printing to catch on, all of these technical and cultural and social elements needed to align. Gutenberg understood the need to develop a contextually appropriate solution. For instance, he designed his typeface to look like scribal handwriting, so that it was consistent with the look of valuable illuminated manuscripts. He didn't want to break with existing culture, or else he'd alienate prospective buyers. Also, since the church controlled the book industry, he, just like us with cook stoves, needed to get religious leaders on board. He made his first product, the Bible, which, as we know, went viral. This was one of the most important inventions in world history because it led to the explosion of knowledge. But it only took off because it was consistent with the social, cultural, and religious context. Today, as in Gutenberg's time, In order to design solutions for any community, particularly in the developing world, it's important to acquire an in-depth understanding of local users and their motivations. It's important to understand how real people live, their culture, and their beliefs. If we do this intelligently, we can solve some of the world's most serious problems. This is the BioLite HomeStove. Ryan and I are 34. By the time we're 40, let's make sure there are millions and millions of these stoves saving lives across India and Africa. Thank you.
Hi, my name is Chris. Health data is notoriously difficult to gather. So could you talk a little bit about the methodology for how you quantified this problem, like how you're attributing these premature deaths to the smoke? Is it condition-based? I would love to hear more about that.
Do you open it?
Yeah, you should take it. I mean, we don't develop that data ourselves, but you can speak to it.
So the data on the magnitude of deaths attributed to household air pollution are provided by the World Health Organization. And the primary deaths are both respiratory disease and cardiovascular disease and cardiopulmonary disease. There's been a big challenge in the global public health community, not around attributing deaths from these diseases, but rather in quantifying the health impact of stoves like these to address those deaths. So the public health community argues that you need a 90% reduction in particulate matter in order to mitigate the risk of respiratory disease. And if we can nerd it out for a second, the relationship between respiratory disease and air pollution is not linear, it's logarithmic. So you need literally a 10x reduction from an open fire in order to have a 50% reduction in the risk factor from respiratory disease. And so the first thing that we as an organization did was have had to validate in our own lab, which is built to the same standards, and Ryan can elaborate on this, as the US EPA, that our stove reduces smoke in laboratory conditions by at least 90%, which we've done so and have also had the EPA and the government of India and other independent bodies independently verify that. We then took stoves to the field and have done studies with independent testing groups like Berkeley Air Monitoring, which is a group out of California, to validate that with the types of fuels that people are using and the way that they're used to feeding the fuels, that it also achieves a 90% reduction in respiratory disease. And we've done that as well. And then the final step is, the gold standard in qualitative or in research methods, which is a randomized control trial. And so for the last 2.5 years, BioLite has been participating in the world's largest randomized control trial of the health impact of this cookstove on young children. And it's a National Institute of Health funded study administered by Columbia University School of Public Health and the Ghanaian Ministry of Health. And the results aren't out yet, but that's sort of the third piece in validating that these stoves have impact on villagers.
Cool. Thanks.
Hey, how does this stove compare with a typical rocket stove design? Is it like basically the same thing or a completely different idea? Or?
Well, totally different in that it's a forced draft stove. So it does have a rocket stove architecture, and for everybody else out here that's not familiar with the rocket stove, it's a basic stove architecture that's essentially like a chimney in your house. You've got this L shape that's properly sized in terms of the inlet and also the outlet of the top of the stove. And so as the fire releases heat, it induces this sort of natural draft, pulls air in from the ambient through the fire, and then comes out the top. And the other thing that's important in the rocket stove architecture is all the insulation that's built around that. And so there's a bunch of insulation between this outer wall and the hot wall inside the chamber, so that all the heat really gets directed directly to the cooking surface rather than lost out to the ambient. So a rocket stove can improve the fuel efficiency, But the problem is, for each gram of fuel that you burn, you're still emitting all the smoke. You're not really getting complete combustion. You're not getting intimate mixing between the oxygen and the fuel molecules. And the fan, with our injection array, getting turbulent mixing at each jet location really is what changes that. So we've used the rocket architecture to improve the fuel economy, and then we've used our air injection technology to make sure each gram of fuel releases 90% less particulate matter.
And did you consider any exhaust solutions? Because, you know, burning the fuel more cleanly is one good way, but another obvious thing that pops in my mind is if the smoke gets exhausted outside rather than just being released into the air inside the house.
Sure.
Like, would there be a plug-in or some kind of a way, or is that just not practical with the way that these stoves are typically used?
It can be practical in certain markets. Ethan showed you the cooking style in Latin America, which is on a wide plancha stove, and those are usually inbuilt stoves that are fixed in place. And adding a chimney to a stove like that can really dramatically improve indoor air pollution. There are a couple problems with that. I mean, for one, you're not really addressing the environmental impacts of all that black carbon. The black carbon is a huge forcing factor on global warming potential, so we'd rather burn it to completion than just dump it outside. But also, there are cultural contexts and daily use modes where the stove really needs to be flexible and people need to be able to put different cooking implements on top of it. So a compact portable stove like this is much more useful and requires a lot less behavior change than something that's inbuilt with a chimney that pipes the flow outside of the home.
Thanks.
Do you do all your manufacturing here, or do you try to have a local supply chain in the countries where you're selling the stoves?
We can tag team this one, I guess. I mean, currently the stoves are produced in China. That's the cheapest way we can generate them and have the quality control that we need for the electronics components. We're working in both India and in East Africa to find options for local assembly and some local production of the metallic parts of the stove. You can imagine that the cast iron pieces and the metal pieces are heavy, they're expensive to ship around the world, so bringing those pieces of the production in country can reduce our tariff rates, it can invigorate local businesses in those countries and also reduce the shipping costs for us. But in order to keep the quality where it needs to be on our electronics components and the fan and some of the internal geometry, we'll probably keep most of that in southern China for the time being.
Hey there, thanks for coming. So I'm curious about a couple of things. One is around your supply chain. I'd like to hear like some of the challenges of getting this product to the people that need it. And you know, things break.
Yeah.
Once they break, what kind of challenges and what kind of solutions have you come up with for helping the people there repair their own devices?
Sure. So the first time that we shipped pilot units to India, I think 40% of them ended up smashed by the time they reached the end user. And it turned out that they were being thrown off the top of trains and buses. And so we had to augment our packaging to address that. One of the biggest challenge in the business model is what we call last mile distribution, which is once you've left a city and have to get the product to a villager's home, the roads are, if there are roads at all, they're very poor quality, and so we've designed these. I don't know if any of you have seen on the back of motorcycles. There are these like pizza boxes sometimes in the developing world. Domino's delivers their pizzas with these like boxes on the back of motorbikes. And so we've designed a similar box for transporting our stoves on motorbikes because our village distribution agents ride motorbikes to get stoves to end user. And we've even designed an apparatus that can allow you to carry 6 of these stoves on the back of the bike in a pretty safe way. Beyond that, we really think that customer engagement starts at the point of sale. It doesn't stop then. And so we've invested really heavily in after-sales service. And so I'll just share a couple aspects of it. The first is that we've set up a call center in each of our markets that follows up with every one of our customers who's purchased a stove first a couple weeks after the point of sale to make sure that they were properly trained when they were sold the product and to make sure they don't have immediate user issues. Then at 6 months and a year after to find out, do they like the stove? Is it delivering on its feature set? Would they recommend it to others, et cetera? And then in addition to that, Ryan and his team have designed the stove to be very, very easy to repair. And maybe you can elaborate on that.
Yeah, no, I'm glad you brought it up. I was going to add to that at the end. But essentially, there's two main halves of the stove, right? There's the metallic stove body that's the heat-containing functional part, and then the power electronics in our power pack back here. And by making those two somewhat modular and really simple to join to one another, we can identify the particular issue that a user might have and address that with just a component replacement that our field agents are very capable of implementing in the field. And so if the stove's been in use for many years, maybe there's some corrosion inside here and they need a new stove body, we can replace that with the existing power pack they have at a reduced cost. If someone's thrown some liquid inside this thing or someone's grabbed it and somehow damaged the power pack, we can bring a replacement power pack and kind of split that supply chain up a little bit.
And currently, our average repair time across markets is 3 days from the point that the customer experiences an issue to the point that it's been solved for. So we've tried to decentralize after-sales service to allow for very efficient repairs. Thanks.
Hello, I have 2 questions. First, I want to know if you had considered creating a bigger opening for bigger pieces of wood. And then the other question is, could you please describe again how you reduce the smoke?
Sure.
Thank you.
I'll take both of those. You must be a stove user yourself, because that's like the #1 feedback we get in the regions that we operate is like, we need a bigger fuel mouth. Oftentimes, people are literally tearing limbs off of trees and lighting the end of it and continually feeding that into the stove. So that's definitely something we're working to optimize. There is a new version of this stove that'll be coming out this year. The mouth has been increased a little bit, but the trade there is that as you open the mouth, you're now exposing all that heat and radiation to the environment. And that's really one of the key factors of the rocket stove architecture that we talked about a minute ago, is that by containing all of that and not allowing the radiation to get out to the world, you're improving the fuel efficiency of the stove. So there's kind of a balancing point, and we're trying to find out exactly where that point is. We believe it's a little bit larger than what you see here, but not so much larger that we really lose fuel efficiency. And in terms of eliminating the smoke, it's really just chemistry. I have a background in aerospace engineering. I did combustion engineering at my previous job, and it's really all about getting intimate contact with fuel molecules and oxygen molecules and making sure they can interact in a place where they're nice and hot. And so in a typical fire, you've got a bunch of fuel coming off of the wood, and then it's got to pull air from the outside to react with that. But there's too much fuel in the middle and too much air in the outside, and somewhere in between is where the flame happens. And where there's too much fuel, often that'll cool off and then be unburned, and that's the particulate smoke, either in droplets or solid particles that get emitted. By injecting air at high velocity, we swirl all that stuff together so that the big chunks of fuel and the big pockets of air get intimate with each other and can really mix and allow that chemistry to happen in the environment where it's nice and hot, and you get complete combustion. All the fuel gets converted.
Thank you.
Thanks.
Hi, thanks for coming and talking to us. 2 questions. What are the metallic parts made of, like the ones outside the bigger parts? And then how does the financing usually work for people who are buying these stoves?
Sure. There's a combination of different alloys in the stove that are used in different locations based on the temperature that they're exposed to, based on the chemistry in the wood, whether it be sulfur or chlorine that may be attacking it in a corrosion mechanism. You see a lot of cast iron on here. Cast iron is attributed to durability in the markets we operate, and people really trust that material. So we always use cast iron on the top of the stove. In this version, there was some cast iron in the main chamber. We've since gone away from that and gone to an alloy that we can use in a thinner wall. We can reduce weight and cost in the stove, which really improves the last mile distribution that Ethan was talking about. When you use cast iron, the stove gets pretty heavy, and so for someone on a motorcycle, they can only carry 1 or 2. The next generation of this thing will be able to carry 4, maybe 5 on a motorcycle and get the same kind of durability by using a higher performance alloy rather than the cast iron. So it's a whole mix, and we work really closely with Oak Ridge National Labs and their combustion and corrosion lab to really find the optimum materials. Typically, really corrosion-resistant, heat-resistant materials are very expensive. So it's another one of these balancing acts where we have to find the right trade between cost and durability. I think we're really close.
With respect to your financing question, in our first year of operations, all of our stoves sold were with upfront cash. So customers would pay $50-odd in cash, which obviously is a substantial amount of money relative to incomes. But to our surprise, we sold stoves faster than we had expected at a higher than modeled retail price. But we realized that we were probably only skimming the more affluent parts of our target market. And so starting in 2015, we focused exclusively on launching what we called credit-enabled distribution channels. So these include banks, microfinance organizations, and producer cooperatives that provide loans to farmers. And in those models, the flavors of financing vary, but for instance, in India, our main microfinance partner sells the stove for, or finances the stove for $2 a month for 2 years. And that obviously has dramatically widened the addressable market of people that can afford to purchase the stove.
Hey there, guys. Thanks for coming. So kind of a two-part question. One is, what's the order of magnitude of like the number of stoves that are in the hands of actual end users? And also, what's like the next, for you guys, like the next like 10x market? Like which market are you most excited about in the developing world?
Yeah, I mean, you've got those numbers at hand.
To date, we've capped production and sales to 15,000 units in order to, A, validate product market fit with customers, B, refine our business model, and C, figure out these questions like around financing. With the launch of the new stove that Ryan described, we're going to have a product that is lower cost with a stronger feature set, which is timed for us to start scaling our operations. The plan is to continue to remain in India and East Africa as our core markets, and to sell 1 million stoves over the next 5 years. Thanks.
Thank you.
Hi.
Hi.
Let's say someone who saw this BioLite in a YouTube or something like this thing, someone in India, and if they want to, let's say, affiliate with you or an NGO member wants to publicize this, what are the steps that someone has to go through to create awareness or to even finance this or sell these things like that?
Sure. Well, firstly, to put them in touch with us, especially with India being a key market, we'd be thrilled to talk to any potential distribution partners, marketing partners, et cetera. We currently have operations in India in the state of Orissa, which is in the east, Rajasthan, which is in the west, and have also run operations in the northeast in Assam, Mizoram, Nagaland, et cetera. And so we have teams on the ground in each of those markets who anyone in your network who's interested can reach out to through us. Thanks.
In terms of size for people, I mean, there have been a number of technologies that have been attempted to use for this, like solar stoves. How do you compare to in terms of size of market and in terms of installed base compared to some of these other things that have been used for the reduction in pollution and the like?
Maybe I can start and you can
go for it.
And forgive a bit of snark here, but as we were saying in the talk, the taste of food is really culturally specific, and from my experience, and there are exceptions, but from my experience, cooking on a solar stove is the equivalent of trying to microwave a steak. And who wants to eat a microwave steak? There are a few problems with it. One, you need a lot of sunlight. And during the monsoon season, for instance, in India, or in the evening, that's obviously a challenge. Secondly, food takes a really long time to prepare on a solar cooker. So it's like slow cooking in the US. So you put the food on in the cooker in the morning, you hope it stays sunny all day, and in the evening you have food. But for instance, you can't make a roti, a flatbread, on a solar cooker. And as I was joking, you probably wouldn't want to grill your steak on one.
Yeah. I mean, you said it great. I don't think there's too much more to add to that, really.
So solar cookers, I think, are appropriate in some contexts and have gained some traction in some contexts. But half the planet, as we were saying, cooks with wood, cow dung, and crop waste. And we really feel, as a business, that our goal is to meet users where they are in terms of the types of fuels that they have available, the types of dishes that they like to cook, and ensuring that the taste is consistent with the meals that they prepared before on an open fire.
So I just had a question about how much of a piece of wood is, say, incombustible? How close, like, what is perfect, and how close are you to perfect when it comes to combusting everything?
Sure. I mean, wood is primarily carbon and hydrogen, mostly carbon. When we talk about burning to completion, we can burn all that carbon. So there's maybe, on an average piece of wood, 3 to 8% that's mineral. And that's the only part that's actually not burnable. So if you've ever seen the leftovers after a fire, there's a lot of big black chunks, which is char or carbon. And then there's little bits of white, kind of stringy, spiderweb looking material. And that white stuff is mineral ash. And that's the only part of the wood that's completely unburnable.
And does the reduction in total carbon ash affect uses that people have for their stoves? Do they have things to do with the ash?
That's a great question, and we see that a lot, although what happens is in some households they're ready to utilize that charcoal, and they may have a specific charcoal stove that they might use, but in a lot of homes it just gets disregarded and passed off. So we feel like it's better for us to go ahead and burn that charcoal to completion, give them all that heat energy for cooking. If they still need to purchase or create charcoal for a different cooking task, that's fine, but I think we'd rather cover all those instances where people discard the charcoal.
And finally, you said you were moving away from cast iron to a different alloy for the inner part.
Yeah.
So that'll hurt your will that hurt your ability to produce, say, the cast iron in country, or I don't know how to describe it.
Yeah, I mean, that's a fair question. And for the specific alloy we're looking at right now, it would probably have to be imported, and then the manufacturing of that from sheet metal into finished goods would happen in country. But I think that could still be a major improvement.
Okay, thank you.
I was just wondering if you could provide just a few technical specs, like what is the total mass? Is there a battery in the orange unit? And if so, what's its capacity? What is the total, power output to the USB port? Some other stuff like that.
Sure. So currently there's no battery in the stove. That adds cost, again, to the product. And so until we can bring the rest of the cost down, we're going to leave the battery out. We are working both in our outdoor recreation markets and in our emerging markets on some lighting options that can utilize the USB power from the stove to provide light, but also have a battery on that side of the system to store things. So right now there's no battery storage capacity. The USB output is about 2.5 watts. So that's very comparable to, say, the side of your laptop when it's not plugged into the wall. If you just plug in your phone on the side of your laptop to charge your phone, it's about the same kind of current flow and power that you see. The next generation of the stove will get another 20 to 25% improvement in that.
And just the total mass of the stove?
It's currently, this is around 6 to 8 kilograms, I believe, and the next one will cut that significantly down below 5 kilograms.
And are you worried, as a possible perverse outcome of this, that people will burn wood that they otherwise would not have just to charge their phone?
Yeah, it's definitely a concern. I know Ethan and his team have looked into that.
So, yeah, this was an initial concern of ours, and after several years of operations, not only have we never seen that happen, but there is a PhD student at Lawrence Berkeley Lab named Danny Wilson, who did an independent evaluation where he designed a stove usage monitoring system. It was actually to our camp stove, which is a product that wasn't even designed for this market. And he looked at whether people are using a camp stove for charging and not for cooking. And again, that product wasn't even designed for cooking in that market. And what he found was not only were people not using the stove just for charging, the version of the stove that had charging, households were using it way more for cooking. So the inclusion of the electricity generation actually increased usage for cooking while they were co-generating power, but did not have the perverse effect of customers using it just for charging.
And just as I often see with really cool products like this, like, you know, it's just not available for purchase here for people who want to play around with it. Like, can I go out and buy that?
So in response to people like you, we launched, I guess last year?
2014.
2014.
Yeah.
Middle of 2014, a version of this product called the Base Camp, which is essentially a backyard barbecue. So it has the same chassis or body of this, but it has a different top, which can be used both for grilling and as a stove. You like flip a lever and it switches back and forth between a diffuse flame for making a bunch of burgers and a concentrated flame for making soup. And it also has legs on it so that you don't have to crouch on the ground. It has a battery on board. It produces twice as much power as this version. And we launched that product on Kickstarter, and I think it was like the 20th most successful Kickstarter product in Kickstarter history. So you can go either to our website or to REI or any other outdoor retail store to buy the Base Camp.
Right.
Thanks.
Yeah, thank you guys.